Okay, page 7 of functions, number 6. A school had 1,000 students in 2016 and 1,150 students in 2019. The number of students in the school has been increasing at a constant rate since 2015. Assuming that this continues to happen, find a model for n of t, the number of students at the school t years after 2015. Determine the number of students at the school in 2015. Okay, so let's make a little table here. So 2016, there were 1,000 students. And in 2019, there were 1,150 students. The number of students has been increasing at a constant rate since 2015. Okay. So the model is for n of t, which means t is the x-axis and n is the y-axis. And t is the number of years after 2015. So 2016 is actually a value of 1. And 2019, let me fill in the missing years, would be 4. Okay? So let's find the model. I think the easiest way to find the model is stat, calc, and reg, right? They gave us 2 points. Can't we find the equation of a line through those 2 points? They said it's linear, right? Constant rate of increase. So we're going to put 1, 1,000, and 4, 1,150. Stat, calc, lin reg. This is going to give us our model. Oops. I think it's because we have stat plot on. Second, stat plot. Second, quit. Second, stat plot. Okay, as everything's off. Stat, edit. Oops, look what I did there. Delete. Okay, stat, calc, lin reg. Calculate. Make sure frequency list is blank. Okay, so the model can be written as n of t equals a x plus b. And notice I put t for x and I put n of t for y. Okay, so there's the model. Determine the number of students at the school in 2015. So remember, 2015 corresponds to a t value of 0. So a t value of 0 would give us 50 times 0 plus 950. So the number of students at the school in 2015 is 950. We could actually put it into y equals and then look at trace 0 to find 950, but pretty easy to do that. Number 7, a linear function f is such that f of 1 equals 5 and f of 5 equals 1. Find the formula for the function f. So let's go to stat edit again. And we're going to put in 1, 5 for this one. And then we're going to put 5, 1 for this one, right? Because this is x and this is y. So 5, 1. Stat, calc, lin reg. Calculate with frequency list 0, or frequency list blank. So our model is going to be negative 1x plus 6, where negative 1 is the slope and 6 is the y-intercept. Find f of negative 3, which just means put negative 3 in for x. Okay, so we can see just by calculating in our head, negative 1 times negative 3 is positive 3, plus 6 is 9. We can see it's 9, but you can also do it by putting it into y equals. So let's do that. We're going to put negative 1 times x plus 6. And then we're going to do second table. And then we can go back to where x equals negative 3. And we can see that the y value is 9. Okay? All right. 5F. The managers of a factory are trying to determine what to charge for an item they make. The demand for the item, a measure of how many are likely to sell, can be modeled by D of P equals 800 minus 2P, where P is the selling price in dollars. D is the demand. The supply for the item, the number that can be made, can be modeled by S of P equals 3P. Find the equilibrium point for them. The equilibrium point is where supply and demand are equal. So basically, we're going to put each of these into y equals. So the first one's going to be 800 minus 2p, but instead of p, we're going to put x. Oops. To x. X. And the other one is 3x. And we're going to graph it, but we need to, of course, change the scale here of the window. Okay, so first of all, the thing is completely off the screen. Well, S is on the screen. D is completely off the screen. So we need to adjust it. First of all, we could do zoom fit, which is 0, right? Option 0. There is D, and here is S, and we're obviously not getting the intersection point. It's going to take a while for them to cross each other. We do need to go further to the right. I don't know how much further to the right. Let's change our zoom, or our window, sorry. And let's change our X max to something very big, like 1,000. And see if that makes a difference. Graph. I think we're going to make them hit each other. There it is. Okay. If you guys ever take Economics 101, we're going to find the intersection here. So we go second calc, intersect, enter, enter, enter. And the intersection is 160, 480. $160,480. Comment on the situation in which the selling price, by the way, 160 is the price and 480 is the demand for the item, how many are going to sell, okay? Comment on the situation in which the selling price is 100. So let's see. When the selling price is 100, let's do second table. And then we'll see what the two values are when x equals 100. To do that, let's jump down to 100, shall we? And one way we could jump down to 100 is we could do second table set and change table start to 100. And the beginning of the table will be 100. And we don't need to, oops. And then we don't need to like graph it or anything. Or we don't have to change the step size. So when the selling price is $100, I forgot which was which. Oh yeah, the first one is the demand curve. So I'm going to write this down. So when price is $100, the demand quantity is 600. And the supply quantity is 300. So you can see that there's a lot more people who want it than people who are providing it. Okay? So that's what you would say, something like that. That more people want it than is being provided. Contrast your answer in part C to what happens when the price is $250. So let's go to table set again. And then we'll change to 250. Oops. 250. Okay. And so at 250, let's say when the price equals $250, the demand quantity is 300 and the supply quantity is 750. So basically things are being left on the shelf, right? Because there's like 750 more, there's 750 units available and only 300 people want them. So there's 450 left on the shelf. So something like that. Okay. Number 3, some friends are planning to rent a car during their holiday. They have two options. Option A, they pay $5 a kilometer. Option B, they pay $150 plus they pay $2.30 per kilometer. This is a very real option, except for normally when you rent a car, there's not option A. There's option B, which is you pay something and you pay additional per kilometer. And then there's option C, where you pay one price and you don't pay anything per kilometer. Okay, anyway, A. Find the cost of renting the car if they travel 100 kilometers under option A or option B. Okay, so if they travel 100 kilometers, then option A would cost 5 times 100. And option B would cost $2.30 times kilometer, fixed cost of 150. So it'd be 150 plus $2.30 times 100, which would be 23. So it'd be 173. Okay, so that was the answer for A. Write down for each option an expression for the cost of renting the car in terms of the number of kilometers traveled, X. Okay, so let's see. For A, it's $5 a kilometer. So it's 5 times X, which is the number of kilometers, right? And for option B, it says it's $150 plus $2.30 per kilometer. Okay? This maybe will remind you of the investigation we did for lines, where we talked about the different options for bowling alleys and how they charge money. Okay, so there's like an initial fee and then a per person cost or per kilometer cost, for example. Okay, so for A, it's y equals 5x, and for B, it's y equals 50 plus $2.30. X. They know that above a certain number of kilometers, K, I'm sorry, is it K? Okay, no. So X is the variable for the number of kilometers, and K is a certain value of X in which A becomes cheaper than option B. So the best way to see that is through the graph, okay? Do you remember when we did that in the investigation too? So A is going to be 5X, and B is going to be 150 plus $2.30 X. And remember, we already adjusted our graph, our window, so that it was like really wide and really tall. It might be okay for this case too. Let's see. So that one is obviously A because it starts at 0. And B, there's B, which started at 150, but it doesn't slope up as much. And so they want to know when these intersect, because when does the red line start going below the blue line? At their intersection, of course. So you do second calc intersect. Enter, enter, enter. And the intersection is 55.56, comma 277.78, which means that when the number of kilometers is 55.56, then the price is $277.78, and that's when the two packages, the two options are exactly equal, and that's when option A starts to become more economical. So, okay, so that's the K values right there. All right, is that it for this page? It is.